Hey, Mr. Albert here. We've been talking about exponents and roots or radicals. And what we're going to talk about now are rational exponents. And rational exponents, rational means fraction. So we're talking about exponents that look like fractions. So down here we have a raised to the m over n. Now when you see an exponent written as a fraction, it's really two things. It's one, a power, which means something multiplied together a lot of times, and a root, which means something broken down a lot of times. But as we write that, the breakdown looks like we could have the nth power of, the nth root of a to the m, or these are interchangeable. The nth root of a all raised to the m. And these should calculate the same thing if it's going to give you a real number. So a lot of times you will see the two on the right here with the exponent and the root. And the common thing is to rewrite it as a single exponent using a fraction. But when people calculate numbers, they think more in terms of roots when they break numbers down. But the example I have down here is 25 raised to the 3/2. Okay? In this case, the 3 is an exponent, so that's 25 raised to the 3rd. And the 2 is a root, so after that it could be the square root. Now if you calculate that, it'll give you 125. A different way of looking at that is the square root of 25, which we know is 5, raised to the 3rd, which is also 125. So it shouldn't matter if you write it as the root of a power or the power of a root. Okay. The main things we're going to work with here are just how to rewrite them, just making sure we understand them, and also seeing that all the exponent rules work with them. So, this here example, we're going to write the radicals using exponents. So the first one is the 4th root of x cubed y squared. So, if we want the long story here, we can say this is x to the 3rd y squared, to the 1/4, because that's the 4th root, and we can write the 4th root as an exponent. And now because everything's in exponent form, we can use our power to power forms. So remember that this 1/4 will be multiplied times the 3 on the x and the 2 on the y. So that gives us x to the 3/4 and y to the 2/4. And if you have a fraction that could be simplified, you simplify it. So we'll write that as x to the 3/4, y to the 1/2. Okay, that's in exponent form. The next one, the cube root of 2x squared y cubed. Okay, so let's do the same thing. Now we're going to do this one a little bit different because of the way I want to. We don't have to, but cube root of 2. We can't break that down anymore, so I'm just going to leave it as the cube root of 2. I could write it as 2 to the 1/3, but I think the cube root of 2 would be better. And let me try and make that 3 a little bit more appropriate there. Maybe the sizing will throw you off. But then separately, I'm taking basically and turn the cube root into a 1/3. So I will have x squared times 1/3 and y cubed times 1/3. So if I clean that up, I'll have the cube root of 2, x to the 2/3, and y to the 3/3 is just y to the 1st. Okay. So we can rewrite these as exponents. Now here we've got some exponents and they want us to rewrite them using radicals. So let's see what we get. First we have y to the 4/3. Well, remember this could be y to the 4th under a cube root. And if we want to clean that up, remember that we need roots of 3, and there's 4 under there. So if we divide 3 into 4, it goes 1 time, okay, and that's the outside exponent, and then there'll be a remainder of 1. So if we do clean that up, we could write it as y to the cube root of y. Okay. The second one here, I've got the quantity 6x y to the 4th, all raised to the 1/5. Now, I do handle numbers and variables a little bit differently. So 6 to the 1/5 would just be the 5th root of 6. And then I can also put under here x and y to the 4th. So since nothing's going to come out, there's not much more I could do with that. If I could pull something out, I would. So the big advantage to this is if you see both exponents and roots, you can make them into kind of like units, or make them in a way that you can compare them very easily. But another big thing is when you have these roots, you can still combine them even though they're fractions. So we're going to simplify these two. We've got x to the 1/5 times x to the 2/3. Now that means the bases are multiplied, so I can add the exponent. So I'll have x to the 1/5 plus 2/3. Unfortunately, those are two fractions and I need common denominator. So if I make them common denominator would be 15. So x to the 3/15 plus 10/15. I multiply the first one by 3 over 3 and the second one by 5 over 5. So I'll have x to the 13/15, and that's going to be an exponent. Okay. The bottom one down here, I have the fraction, and on top is x to the 3/2 times y cubed. And then in the bottom of the fraction, I have x to the 1/2 y squared. I'm not sure why I did that. But we know that we can combine x's and we can combine y's. And since they're divided, we can subtract them. So I'll say x to the 3/2 minus 1/2. I guess I made this one pretty easy for me. And then y to the 3 minus 2. And if I clean that up, 3/2 minus 1/2 is 1, so x to the 1st. And 3 minus 2 is 1, so just y. So there's one that had a bunch of exponents and roots hidden in it with a fraction, and it simplified down to just x times y. So when you see roots and powers together, you can write them in just powers, which usually makes them easier to visualize and compare.